All right, friends, we're back again. Now we have seen the theorems. We want to look at the applications now in the questions that you're supposed to interact with. I have a few past questions for you in the WASSCE exam. So let's look at it as we go along. Make sure you take note of the theorems. I've given you a series of theorems. We're going to apply them here now. So I'll be stating the theorems. I'm moving along. Will you move along with me? Let's go. First, we said there was a theorem that I gave you. Said the sum of opposite interior angles of a triangle equals to the exterior angle. Remember that the sum of opposite interior angles of a triangle equals to the exterior angle. So looking at 2018 is to find the value of x. So we want to find the value of x looking at the theorem. It says that this sum of this plus this must be equal to this exterior angle. So if I have x plus 90 must give us 3x plus 15. That's the meaning. The sum of opposite interior angles equals to the exterior angle. So I find x minus 3x is equals to 15 minus 90. So what I did was to transpose over there. Watch this. Now we have minus 2x is equals to minus 75. So if I divide both sides by minus 2, I'll have x equals to 37.5. So watch out for that. That's 37.5. That is half of 75. So now look at it. That is the value of x. Now the second question says that let's also find RSQ. That is RSQ. So sorry, this RSQ. This is the angle in the middle. That's what I want to find. Let me call it y in that case. So if I want to find y there, remember it is y plus this angle here is 3x plus 15 must be equals to 180. That's angles on the straight line. Remember that because we said that angles on the straight line will sum up to 180. That's why I gave you 180 here. So now check this. This is y we want to find. That's the y there. Y, but you already know your x there. So we have 3 into 37.5. That is 75 plus another 37.5. That's going to give you plus 15 is equals to 180. So if you have your calculator there, you can give me the accurate answer there. Now this 37.5 times 3, that's going to give us something like 75 plus 37.5. So if you can just add that, you see the description. This is going to be 100. This is this 30 plus this is 100, 112.5. Watch out there. This 112.5. So I have 112.5. Now plus 15. Now I can clean this question for you here. I can clean this so that I just wanted you to avoid the calculator. Sometimes you don't need calculator there. This is plus y equals to 180. So now if I transpose that, I'll have 127.5. Watch out. This is y plus 127.5 is equals to 180. So watch this. This is y equals to 180 minus 127.5. So check this the subtraction there. Remember it's 127. If I take that from 30, I'm going to have like 2.5. 2.5 is going to give you now 152.5. Watch this here. This is 152.5. Sometimes you don't need a calculator. You just look at it randomly and solve them there. So watch this. I've just be able to substitute this. I said this is 37.5. I just substituted this 3 times that stuff, gave me that, and I have 15 plus that. This gives me that. So if I transpose, I will have the answer like that. This is y. This is now the value of y. I've already given that stuff there. So watch this. The second one is about 2014. 2014 is November private WASSCE. That's your exam more. So we look at this. This is now, if I can remind you on the theorem that I gave you before, I told you that the angle which the chord and the tangent makes at the point of contact is equal to the angle in the alternate segment. So watch here, this must be 21 because the angle which this chord and this tangent make at the point of contact is equal to the angle in the alternate segment. So the whole angle here is 100. So if I remove 21 from there, I'm going to be left with 79 somewhere there. This is 79. Just like this is 21. This is 79. If I add the two, I must be able to get 100 over there. So now if you check this angle and this angle, they have a connection. So if this is 75, 79, this angle also must be 79, because we said angles in the same segment must be equal. So if you check, if I draw it that way, I'll have this. Now if you check this, you have this. So what I've done is Q, this is P. I said this is 79, so this is 79 as well. If this is 79, then this angle must be 79. So you cannot find your S. The guy says find SPR. SPR. So from SPR is equals to the angle in the middle. The letter in the middle is not the angle, so that is 79. SPR is going to be equals to 79. How do I get it? I said it is this angle here is equal to this angle, and if I remove 21 from 100, I'll be left with 79, and this 79 is in the same segment with this one, so these two angles are equal because they're the same segment. So the same idea, watch out. If I now look at this, they say find QSR. You're finding QSR, so I'm finding here Y. They call it Y. Now watch, this is a diameter, so this whole angle must give me 90 degrees. Watch. So if I get this, I have something like this. This is 90, this is R, this is Q, this is S. Now I've said this is 79 and this is 90. So if I want to find that Y, that's this angle here. This is QSR, QSR, that is that Y I'm finding. So I have Y plus 90 plus 79 must be equals to 180. Angles in a triangle. Angles in a triangle must sum up to 180. You know that already. So now we have Y plus, if I add this together, I'll be having something like 169 equals to 180. So if I remove 180 minus 169, so you'll be left with 11. So that Y is QSR is equals to where Y, which is now equals to 11 degrees. So you must be able to figure out that. So that is 2014 November. Watch out how I did it. I said this angle connect this angle, because we said the angle which the chord and the tangent makes at point of contact is equal to the angle in the alternate segment. So if I know 21 here, then this whole angle is 100. I remove 21 from 100, I'm left with 79. That's how I got the 79. But the 79 is going to be in the same segment as this other 79 over there. So this is 79 too. So if I know this, then it is equal to my angle I'm finding, the first guy, SPR. SPR, that's 79. Now if I want to find this other angle here, it's going to be 79 plus 90. How did I get 90 over there? This 90 is because this is a diameter. It's dividing the circle into equal halves, and we said angles formed in the semicircle must always give us 90 degrees. So this guy gives me 90 degrees. So 90 plus 79 plus Y gives me 180. That's how I got the other one there. So watch, this is about the first theorem. The first theorem, we said the angle which the arc of a circle sustains at the center is twice any other angle formed on the remaining part of the circumference. Sometimes it's just the theorem. If you know the theorem, then the work becomes easy. So watch here. Now it is, if I apply my first theorem there, let me call that angle M over there, and that angle is the angle subtended at the remaining part of the circumference. But according to theorem number 1, says this angle from here is going to be equal to twice that angle up there. So it means that twice of M must be equals to 124. Watch out for that. Now I have this divide this, so M must be equals to 62. So if M is 62, and sometimes the circle geometry becomes complex when you have to draw hidden lines. Watch out for that. That's one of the things they'll be testing the question. That if I have 2 points on the circumference, then I have automatically inbuilt chord in there, or I have a radius there. If there's a center of the circle, there's a point on the circumference, I already have an inbuilt radius. They will not give you the radius, but it's there indirectly. That's what is happening here. I have the center here, then I have a point on the circumference. So there is already a hidden line somewhere there, and that hidden line is a radius. And because I have a radius there, then I know that this angle, this radius here, is going to be equal to this line here, because it's also another radius. And because the two sides of a triangle, this is not a whole triangle. If you take that one out, you have this. So you have A here, you have O, you have B. So this equals this. So it has developed the triangle that I told you about. I say watch out for the isosceles triangle. Base angles must be equal. If it is isosceles, then the base angles must be equal. But he gave you one of the base angles. He said this is 30. So this one also must be 30. because they are base angles of isosceles. How did I know? It is because the line is moving from the center going to the circumference is a radius. This one moving from the center to the circumference is another radius. So because of the two radii, they form that isosceles angle and the triangle. And the isosceles triangle property says that the base angles must be equal. So if 30 is here, this one should be 30 already. So now if I move 30 away from that 62, remember the whole angle there is 62. So if I take out 30 from there, I'm left with another 32 over here, because 32 plus 30 give me the 62 there. So the whole m, I've divided the m into two portions now. So this other line is also a radius, this is a radius. So if this is another isosceles triangle, this angle is 32, this one too must be 32. So this will help me now to find this. That's x, which I'm finding, and that angle, that is a straight line. So if I have 32 somewhere there, then I have x there, then I can find x plus 32 is angles on a straight line, because it's a whole straight line. So x is now equals to 180 minus 32. So if I subtract 180 from 32, I have 48. So you now have 148. Sorry, you have 148. So 180 minus 32 will give you the 148. So this x, which you are looking for, which is OED, is equals to x is equals to 148. Don't forget to conclude. In the exam, you have to conclude, because you are not asked to find x. You just inserted your x there, but you have to find the angle this. So you have to label the angle as you move on. So this is 2006 again. Watch out. The same theorem. You can see from what we have done so far, we are applying the theorems that we have learned already. So watch this here. This one tells you that if you can remember the cyclic quadrilateral stuff, I told you that the sum of opposite interior angles of a cyclic quadrilateral, they must be supplementary. So watch out here. It means that 105 plus 31 plus y must be equals to 180. Watch that. It means that the opposite sum of opposite interior angles of a cyclic quadrilateral must be supplementary. So now I have 136. 136 plus y will give me 180. So now if I remove that from there, I will now have 180 minus 136. So if I remove 180 from 136, meaning I'm going to be left with something like 44. So 44 here will give me y. So y equals to 44. When we're looking at x, if I draw this segment again, I will have this. Now you don't need to solve for x even. It's just by labeling, you connect it together with one. This is 31 and this is x. You can see that this is a whole segment. So x and 31, they are in the same segment. So you can conclude that x is equals to 31, because in the same segment, angles in the same segment, you can figure out that like that. So watch out. So I have used almost 4 or 5 of those theorems I just stated here. Check the last one over there, which is 2001. The same. Now sometimes if you look at the first theorem I gave you, I said the angle in the center is twice the angle formed on the remaining part of the circumference. So it doesn't matter where the point is on the circumference. It could be any point. So now if I have this, let me label here as y. So the same law which says that y was equals to 2x. Remember the first theorem, the angle which the arc of a circle sustains at the center is twice any other angle formed on the remaining part of the circumference. And as far as this chord is concerned, the remaining part of the circumference is all of this there up to here. They're all part of the remaining part. So and that's angle there is angle 25 is formed on the remaining part of the circumference. So therefore y is equals to twice of that, 25. So y must be equals to 50. Now but watch out, when I was concluding on the theorems, I gave you the angle properties of triangle. I said that isosceles angles, they always have the same base angles. So now I have got a radius somewhere there, I've got a radius somewhere there. So this is O, this is P, this is Q. So now if I've got y in the middle here, which is 50, and this is a radius, this is another radius, so it forms an isosceles triangle. And isosceles triangles, their base angles must be equal. So this angle here must be equal to this angle. And remember, the sum of angles in the triangle, they are 180. If this angle here just took 50, so the remaining is going to be 130, and 130 must be divided between this angle and this angle. So this is going to get like 65, and this other guy will get 65, because 65 plus 65 gives plus 50 must give us 180. So now the angle says, the question says find x, and that x is one of the 65s over there, so x is equals to 65. So you can see that we have almost used 4 or 5 of these theorems over there. So check, I've used the properties of triangle here. I've used the theorem of tangent over here. I've also used the center angle here. I've used some of integral angles over there. So now you can see that you can go through the exam, the questions correctly if you cannot actually master the theorem. So your advice, as I'm moving along, I still have more examples for you, but try as much to master the theorem. As you can see, it's demonstrated here. If the theorems are not in your head, you can figure out this stuff. So let's go to the next example.